Good morning, good afternoon, and good evening. Welcome everybody to another session of Thought Leadership from Infrastructure Masons. My name is Romain Trenchant. I'm the chair of the Innovation Committee, and it is my pleasure to bring you in for a new format that we've got this year to talk about thought leadership. We're going to bring in three different speakers, all align around one central theme around AI data centers today. Talking about different aspects of it. We've asked them specifically to do 10 minutes presentations on their own topic of knowledge, and then after that we're gonna bring them all back in the room and actually go through questions, answers, and actually take your questions through the comment section. So by all means, go ahead and use the comment sections that we've got in the top right corner of your screens. Just pour your questions in there. You feel free to actually say hi to everybody else in the room and tell everybody where you're from. So that's it for me for now. We're gonna get started with Pritesh Indore from Crusoe, who's gonna talk to us about site selection 2.0. So let's go right into it.
Hello,
Pritesh, how are you?
Good. Hello, everyone. My name is Pritesh Indore, and I'm the senior construction cost estimator here at Crusoe. And today I want to talk more about site selection 2.0. Want to challenge these fundamental assumptions that is going around for a while, that site selection for the AI data center is still primarily a real estate decision. But my thesis is that AI doesn't care about latency. All it cares about in today's world is about gigawatts. So let me start the presentation.
All right, here you go.
All right, so we'll talk about is the ALI model dead, or why AI is changing the map. So let's dive into it. So basically, the Northern Virginia is crown jewel of data centers. We all know the data center alley paradox. Northern Virginia has roughly 300 data centers. All of them are ranging from 50 to 200 megawatt buildings, roughly 300 facilities. But the PJM interconnection, which is the utility network in that region, they have the wait time which is stretched over 8 years now, and the queue swelled past 250 gigawatts. So customers are waiting up to 8 years to get the gigawatt into their building, and PJM absorbed an additional of like around 9.4 billion in electricity bills during the summer of 2025 alone. The NRDC estimates the total burden could reach 163 billion through 2033. So the data center alley is hitting the power wall, and that is what driving the new site selection criteria in today's world. The rise of gigawatt scale AI factory. We all know that nowadays current AI compute demand is so huge that 50 megawatt buildings are not enough, and we might see like more and more gigawatt scale AI factories in coming future. So particularly I wanted to talk about this very famous project Stargate, which was recently announced last year with collaboration of OpenAI, Oracle, SoftBank, 500 billion of total committed funding and 10 gigawatt targeted by 2029. Main sites in that projects are Texas, Ohio, Michigan, Wisconsin, and as of early 2026, 8 gigawatt capacity is already planned. 100,000 plus jobs are already created. Some buildings in Texas are already operational. A lot of heavy work going in Ohio, and then scale shift is staggering. Project Stargate alone represents 500 billion of commitment investment across multiple sites. These projects are choosing sites based on power availability, not on fiber proximity. Texas leads because ERCOT's relatively faster integration options are available. Ohio, Michigan are right there in competition, but Texas is kind of front runner. And as we go on into the presentation, we'll figure out what are the factors those are driving this site selection and why you're seeing Texas more and more in recent news. So there are four major pillars of modern site selection, and this is what's separating the great site from a standard asset. The So this slide really focuses on what really drives the site selection decision day to day. The power is a gating factor. You can have the cheap land, great incentives, but if the interconnection is like 8 years as compared to Northern Virginia, it doesn't really matter. Labor availability drives your construction cost and schedule. State policies can make or break your timeline depending on when can you actually start construction, when your permit's gonna be ready. And land logistic determines the long-term viability. The best site selection team evaluation is based on all four factors simultaneously: your power, your labor, state, and land and logistics. I think labor is going to be the major driving force in coming future, as we are seeing like there is a shortage of electrical workers, mechanical workers, and there are less workers available and high competition. And as NVIDIA's co-founder Jensen Huang said, like next generation of millionaires will be electricians and mechanical labor. So labor is gonna be one of the main driving factor going into the future. So moving on to the state incentive war, the states currently are in the arms race. Texas has Chapter 313, if anybody know, which is a successor program. Mississippi recently passed the AI Data Center Incentive Act. Wisconsin is partnering with Foxconn era infrastructure. And then common thread is like governors are using executive authority to fast track the approvals, get more and more data center into their states. The legislature are passing like targeted incentive packages and workforce pipelines availability as well. Our company Crusoe is heavily working on collaborating with universities and establishing university programs and the transition from adjacent industries such as oil and gas and like pivoting that towards data center job. So Crusoe is doing great work in like driving the workforce pipeline, especially in Texas. So these are the factors and the competition out there. And then another slide, I wanted to talk more about the electricity and the electrons. The paradigm is shifting from consuming grid power to generating your own power nowadays, because grid has longer wait times and generating your power can be the ideal solution in today's world. There are three different types of behind the meter integration innovation going around: SMRs, your solar plus battery energy storage system, we call it as BESS, and co-locations as well. Solar and BESS is already viable in Sunbelt states, and we are seeing more and more BESS system being implemented into the data center. And FERC's December 2025 ruling was a game changer for co-locations. The companies that control their own electrons will have the massive competition and advantage going into the future. And then moving on to the next slide, the new site selection playbook. I wanted to summarize like what were the driving factor for old model of data center and what are the new criteria, new model. So basically, older model data center alley was mainly proximity to the fiber hub, but current data center model and new gigawatt scale factories, they are being considering like proximity to power as their primary driving factor in terms of selecting the sites. Energy procurement, geopolitics, behind the meter integration, and all those are like the front runner factors over your real estate driven decisions and your grid as a sole power source options. So data center is no longer a real estate job, it's becoming geopolitical and energy procurement job. And then professional who understand the power market, grid interconnection, state incentive, and behind the meter integration will define the next decade of AI infrastructure. So things are changing a lot, and we are getting over the old model of data center alley. And in the coming future, you will see more and more data centers. And if you look at the overall map of data center, you will see the DC and metropolitan area with a high number of data center. And if you look at the same map after 4 to 5 years, you're gonna see the data center spread across Midwest, where the land is cheap, proximity to power, and then all the government policies and geopolitics are in support. with this big construction of gigawatt factories. So that's all from my side, and over to you, Roman.
Yeah, Pritesh, thanks very much. What an insightful presentation on where data centers will be implemented in a very near future. I really can't wait to bring you back for the Q&A. I've already got a couple for you, but we'll leave that to a bit later. We're actually going to bring in Eric to the stage. Hi, Eric. How are you?
Doing great. Appreciate it. Thanks for inviting me to be a part of this.
Yeah, that's an absolute pleasure. So I'm just going to bring your presentation up to the stage here. Future-proofing scale. So definitely working at scale as we see the number of megawatts turning into gigawatts in recent years. Really looking forward to what you've got to say about this.
Yeah, I mean, as Pritesh alluded to and spoke directly to in his presentation, we've got more than one type of data center these days. Historically, Stream's been around for 25 years. We've developed, a pretty strong history of cloud type AI or cloud type facilities, and those needs aren't going away either. So while Crusoe and Pritesh are spot on in terms of how site selection is changing very significantly for heavy AI use. Really what we're focused on these days is still an ability to serve our customers across all data center typologies and markets. So what does that mean? In today's era, the most expensive thing you can own is really a decision that you can't change. So how do we stay flexible and agile and serve our customers where they need it most? Part of that is really managing the time cycle of a project very intentionally. How do we understand where, not necessarily where every customer is headed, but where the market generally is headed? What are the needs? What are the shifting demands of the hardware that are going into our facilities? Is it going to be a cloud facility? Is it going to be an inference facility? Is it going to be an AI training facility? All of those result in very different typologies and lead to very different types of development. So we start at square one with site selection. We choose sites that still kind of fall in between the model that Pritesh described and the traditional model. So we still focus on primary core markets, sites that are large enough to be flexible, and power requests in the same vein. So this cone of uncertainty is a great way to describe a typical project. As we're looking at land, as we're trying to develop power agreements, there's a lot of uncertainty. We don't know if we're going to have a customer come in and want still a 40 megawatt critical data center or a gigawatt scale campus. So we need to be able to accommodate both and push as many of those decisions as far into the project cycle as possible. So how do we do that? Number one, selecting good sites, understanding history and where customers want to be. And really that decision between buy versus build has changed. So historically, we've seen all of the hyperscalers do both. And when we've seen them develop their own facilities, those tend to have extremely long project life cycles, long development timeframes, longer build times, and a lot of times higher cost as well. So bringing in a third party historically has been slightly less customizable, but faster. Today, hyperscalers need both. So how do we feel like internal capacity delivery in terms of flexibility and customization while still delivering on speed and a quality product? So we have what we like to call a set of ingredients, our configurable kit of parts. And whether those ingredients, whether the example that we like to use is flour, sugar, salt, and some specialty ingredients. And whether you make pizza, pie, cookies, bread, you can do all of those with the same set of ingredients. So we try to do the same thing with our equipment. We try to defer those key decisions as far into the life cycle of a project as possible. And we can do that with a standardized but configurable set of interchangeable parts, particularly our mechanical cooling systems. Whether we're looking at 100% air and 100% liquid, or just purely 100% air, we have the flexibility within our designs and our equipment to accommodate everything in between, within a standard range of total critical capacity for a facility. Yes, data halls can become less efficient if you put in 10 1 megawatt racks versus 1,000 10 kW racks. But at the end of the day, systems are designed and functional in either scenario. Now, as we get into more extremely high dense scenarios, extremely high capacity projects, we can still use that interchangeable kit of parts, those same pieces of equipment deployed in a different fashion, using our partners and our suppliers. And really, that is the key here, working with people who understand how we work, understand how we like to deliver our product, and are prepared to be flexible along with us late in the game. So we do rely heavily on both our design partners and our construction partners, as well as our vendors. And we've built those relationships over a long period of time. So just as important as being flexible these days is also being transparent and being upfront with the community that you're going to be building in. This has become an extremely important topic within the last 18 months as we see significant community backlash. We need to get better as an industry in talking about all of the positive impacts that we bring. I just reposted a paper produced recently on electricity prices and the impact of data center development, and the findings were that there's no robust correlation or causation between a data center coming into a community and electricity prices rising due to that data center. So again, as an industry, being able to talk about how we develop facilities, the costs that we take on and we pay directly for infrastructure upgrades, which benefit local communities around us, as opposed to leaving it to an assumption that those infrastructure upgrades are going to be required to be paid for by common ratepayers. That's one topic that we need to get better at talking about. Another is water use. Yes, there are facilities that do use evaporative cooling and water. Currently, at the moment, stream facilities do not, and many facilities designed and built over the last 15 years are in a similar position, where we have a closed loop air-cooled chiller plant. Once we fill that system, that water never leaves the system. And during ongoing operations, we actually use less water than an office building of the same size, because all we're using is sinks and toilets and such. So being better about how we talk about what we do, being transparent with communities around us is really extremely important in allowing the entire industry to continue to develop at the pace that we're currently going. So we have other resources available. If folks want more information, you can find a great community engagement white paper on our website where we talk about our engagement with the city of Goodyear. Just one example. Here's a few of those stats. It's a large campus, not AI density, but we've worked very, very closely with the city for a number of years and look forward to completing that campus as a good partner and kind of setting the standard for how to work well in the communities that we develop in. So Romain, that's all I have for now. Looking forward to answering questions later.
No, that's fantastic. Thank you very much, Eric. You absolutely had me at cookies and pizza, to be fair. I suddenly got very, very interested. No, I really appreciate it. There's a lot more to discuss. I'm looking forward to bring you back for the Q&A. Let me bring JP to the stage. JP, thanks very much for joining us today. Really appreciate it. I'll just remove that presentation and bring the next one in. There you go. All right, perfect. Well, JP, thanks very much again for coming in. We're going to be talking about AI waveform mitigation, so along the same lines, looking at the impact of AI data centers into the bigger scheme. So the floor is yours.
All right, thank you so much for having me, and I appreciate the presentations from the previous two speakers because I think it builds upon everything. Setting up some framing about empowering that digital core that we're inside of. If you think about the data center value chain, right? So I think we talked about site selection, about combining those assets of land, power, water, and fiber in order to make a facility. And then I think Eric got into how do you want to design and construct that facility to get through those risk activities to either, if you're a co-location company, ready for service and start generating revenue. If you're infrastructure as a service company, generating revenue there. And then finally to the software as a service or the agentic as a service now. How to get that end revenue so it's a sustainable value chain is important. And that's what we've been chasing. And for the last, from 1990 to 2020, it's been relatively, stable, right? We went through one order of magnitude for rack densities from 3 kW rack to 17 kW rack inside the United States, or 20 kW a rack if you're 100% rated breakers outside of the United States. Back in 2020 to 2025, we had this acceleration from that 20 kW rack to about 120 kW rack with the advent of higher density clusters. And we have a projection to go higher again. So in the time frame, by the end of this decade, 33% of the time it took to do the first magnitude of change, we're going to go through 2 orders of magnitude change. And that's where a lot of that risk that we've been talking about, I think what Eric talked about, comes into play. Now, to think about the first principle that's driving this is important because it gets to that AI waveform mitigation and also fault ride through that's impacting the industry. So the network and the packet loss for these clusters really would drove that piece. So if you have a checkpoint or if you have packet losses in these really large clusters of 4,000, 10,000, now over 100,000 plus GPUs linked together, having a packet loss in the TCP/IP protocols used to be fine. We're all talking on a stream service, and if I lag, that's fine because it'll just keep going. But in AI, it's really affects that checkpoint and it affects the end revenue model. 20,000 GPU cluster rented at $2 an hour is roughly about $3.4 million a week for an IaaS customer, and 3 to 5x of that for the end SaaS or agentic customer. So back in 2020, we had increased densification. You might have heard of NVIDIA or AMD densifying those racks. The NVL72, I think, is a lot in the market right now. And you went from a 700 watt chip to a 2700 watt chip with the GB200s. And additionally, you wanted to put 9 racks into one rack of 600 millimeters wide, 1200 millimeters deep, and about 48 rack units high. That presented a problem because the thermal cooling layers that we used before, we didn't have space for that anymore, and we had liquid cooling. And that transition caused further densification that we're going through right now. And some of you might have heard about the direct current that was announced, last year at OCP and reinforced at GTC last week of the trend in that space. What's that really doing is affecting, and that drives the direct current, right? So that direct current's impacting overall what's occurring. And that layered upon the increased portion, which I think Eric touched on, about a modular nature of a data center, and thinking about it, and how I think about it is in multiple different ways. Those multiple different ways is block one or the grid interconnection with on-site power generation, and the high voltage to medium voltage transition, moving into the gray space, medium voltage to low voltage with power quality. That might have UPSs, that might have other items in there. And then inside that white space or the IT module, and then the cooling or the heat rejection mechanism, and then that software layer of how we actually orchestrate that off of ever-increasing campuses. The key here is in the center of the IT module, that's what's really changed. For the last 30 years, from 1990 to 2020, we could just delete racks and be fine. But now we're seeing 6 different functional requirements. One being the traditional compute that we used for the last 30 years. The next one being the network, where if you lose the network, many data center operators know you might be down for 90 days just logically rebuilding it, and that's just from a power cycle. Then you have the HPC air-cooled, the HPC liquid-cooled, and beyond that, the quantum computing and the modular edge computing. So all that's happening inside that white space, and that's the modular nature where you then might have to bring in different cooling apparatuses or different power apparatuses to serve that piece. Why that's important is because we've linked a data center with 40 megawatts or maybe 100 megawatts all running the same application, that causes issues on the grid. And the fact that we've become such a large load that a disturbance on the grid that causes a brownout signal at 80% on that 27 relay or under voltage relay on your low voltage main switchboard might cause a trigger to flip to diesel generators. The biggest fault in the entire globe right now is the entire power system was predicated on one assumption, and that the load would remain constant or come back instantly, and generation had to be regulated. We're seeing things in Brussels, in FERC, Senate Bill 6 in Texas, Australia, and also Malaysia, that operators have realized this, that we actually have to regulate or at least coordinate with the faults in data centers on how we've done our redundancy protection. Because all of the designs have been done such that we protect the load and the IT load, not necessarily protecting the grid. We saw in Spain that was a significant problem when we lost power in Spain. In Northern Virginia, same fault occurred, and that fault caused a significant change in that grid. And we were able to catch it because luckily the East Coast of America's grid is one of the largest in the world. And it was able to absorb that, but it caused significant actions needing to be taken care of. The next portion is that shift to direct current and the AI waveform mitigation of how do you take the oscillations or subsynchronous oscillations that might cause resonance danger to the grid itself, but also the on-site generation, and how do you use that medium voltage to low voltage transition with power quality to mitigate that, in order to serve and maintain both load and stability on the white space, but also being a good grid citizen, or as Eric was talking about, a good neighbor in engaging the community. Where that comes in through it, we're looking at a multi-stage strategy. And if you look all the way over on the right-hand side of this screen, you can see in red, that's the AI waveforms from the GPU clusters. And we're thinking maybe an active harmonic filter of some sort, whether inside the rack, but eventually that most likely will be removed outside the rack due to the space premiums that are causing us to densify the racks. Then you go through utilizing the UPS technologies to help mitigate that and making sure you're testing associated with that. And then finally into a grid interconnect, you might be using a combination of a BESS, your on-site generation, but thinking of this as a multi-stage approach. And depending on the applicable region or zone, that matters. I'm going to call out here that this is something that has been value engineered out, but the UPSs in many of the data centers have been value engineered out over the last 30 years. If you remember the 2N power that we did, and then we try to figure out cost reductions associated with that, that many of the AI clusters have a single bus bar or a single track or a single RPP whip, and then you value engineer the UPSs and exposing those GPUs to raw grid voltage. That's not necessarily the focus of this in particular, but those things need to be thought through because as you go from driving a Honda Civic or a semi truck and going to doing a Formula One car, those overvoltages, undervoltages coming from the grid that's unregulated will impact the overall grid. And thinking through those things is important, and talking through that. I'll pause there because I think my 10 minutes are up, and I will turn it back on over.
Fantastic. Thank you very much, JP. You literally have 30 seconds left. So one last comment for the presentation.
All these challenges are solvable, right? And we can do it together as an industry. It's all about working together with the communities, industry peers, and of course, using the iMasons network as part of that as well.
That's fantastic. Thank you very much for the last few words. Let's bring everybody back in and go through Q&A. I can see already a debate brewing in the comments, so it'll be interesting to get everybody's impression on this. All right, fantastic. Thank you very much for all your presentation. I think, and hopefully, but maybe we might hear in the comments about the format. It was great to have like 3 different viewpoints, not competing, just all adding onto each other and actually telling us a story. So hopefully, that's a good format that we can carry on in the future. Let me start with a question. And it might come as a bit of a curveball. You guys are all in the US. Everything you said here, does that apply to the rest of the world?
Yeah. So like I referenced Sydney, I referenced Malaysia, I referenced Brussels. Actually, the fault ride through an AI waveform mitigation, those solves have already been somewhat implemented in those areas because Australia has a very stringy north to the south grid. Europe has isolated grid stability, and really it's really EMEA and East Asia that's leading the solution sets, because the United States didn't see that fault ride through AI waveform mitigation because the grids were so big. That's why you see Senate Bill 6 coming in Texas right now, whereas this has been a robust discussion in Europe for quite a bit.
Thank you, JP.
I would also argue that trying to late bind decisions, trying to be flexible and be a good partner with the folks going to occupy your facilities, that is location agnostic. That's just kind of a way of working. Yes, we currently solely develop within the United States, but that model I think is pretty applicable across the globe.
Yeah, and I'll echo on what JP and Eric said here, Romain, that the framework here is universal and the variable change by region, but the decision logic is of course the same. Power availability and timeline, it's still the number one gating factor globally. Cost escalation modeling, cooling strategy trade-offs, community engagement principles, they apply everywhere, whether you are in Texas or in Tokyo. So.
That's fantastic. Thanks very much for clarifying on this, because I know we've got people from pretty much anywhere in the world listening to this, and that panel is actually going to end up in our podcast series. So I know some people wanted to watch the recording later, so that's going to be very interesting. I've got a question from Albos here, and I'm just going to bring that on the screen. A question for all 3 of you, from your perspective seats in design, equipment, and cost estimating. Where is the biggest data disconnect occurring today when trying to get a unified, board-ready business case approved for a new data center campus? Who wants to unpick that one?
So if we're talking about capital in terms of board-ready business case, and how do we make sure that we've got a solid business plan prepared? We've got to remain flexible in that way as well. So we'll obviously need to lock down land and, in some sense, power in order to be attractive to a tenant. But the scale of these developments these days, we're not talking about a single billion-dollar campus anymore. And Pritesh, I think, shared $500 billion for one of the Stargate projects, or the Stargate projects as a whole. That's orders of magnitude different from historical data center development. So Typically, it does require tenant interest or a tenant in tow to be ready to go for full capital on projects of this scale. Now, are there incremental things that we can do along the way to help shorten timelines, move the project to the right without having a tenant ready? Absolutely. And each project is going to be different depending on what's necessary. I can prepare soil for development. You can do that without a tenant. Those costs are the same whether you're developing a cloud facility or an AI facility. You need to have a substation. You need to have power infrastructure available. Again, those costs are the same regardless of what type of tenant you're going to have, as long as your campus is of a certain scale. So being thoughtful about how we deploy capital when and prepare ourselves to shorten timelines to deployment.
Yeah, and Eric, you covered most of the things, but I also wanted to talk about what makes a site no go, even though you have a solid business case ready. The three deal breakers are like power can't be delivered in timeline window that is in your plan, environmental or geopolitical risk that blew up your permitting, or local political opposition that can't be resolved. These are your factors which makes that site which makes your business case to walk away from that particular site, even though it looked great on paper, because one of these are like key factors driving your future development of that data center.
Yeah, fantastic. JP, do you want to comment on this?
Yeah, I think it's just agree with the other two comments, but if you can articulate the path to revenue and sustainable revenue with mitigation of the risks, that's what the board wants to hear, right? It's you're going to deploy capital. When are you going to get that return on the capital, and how are you mitigating the risk? Power, of course, and local community involvement. Those two things will be the largest drivers for stops. All you have to do is change the IT hardware refresh tax abatement, and that will usually stop a project if you have the power and everything else. And the way that changes is community involvement.
I wanted to bring something. Is that we are a thought leadership and innovation panel after all. We've talked about site selection, we've talked about design, and we've talked about deployment in general. We have seen a tremendous amount of change, or at least a tremendous amount of innovation coming to market. How do you guys cope with it? How do you handle it? How do you make sense of it? How do you incorporate it in what you're doing? Eric, great quote earlier. Whatever we're doing now, we're going to have to live with it for the next 20 years. For better or for worse, feels like marriage overall. You know, we've got to choose wisely, right? How do you go about it in your respective roles and companies?
Yeah, I mean, that's a great question. And I think a lot of people assume that there's massive innovation happening on the infrastructure side of the data center space. And honestly, we haven't figured out how to break the laws of thermodynamics yet. Once we do, I think we'll all be scratching our heads. But at the end of the day, we're still talking about heat exchangers. We're still talking about heat transfer. We're looking at some new fluids and some new ways of moving heat around. But really, it's applying the same concepts in different spaces within the facility and at different scales. So while there is massive innovation happening on the compute side of the business, we're still applying a lot of the same theories and concepts and processes when it comes to at least mechanical cooling. The power side, JP alluded to or spoke directly to, moving to DC power. And that is something that we are all investigating. We're trying to figure out, what does that mean in terms of safety? What does that mean in terms of different pieces of equipment? We have folks far further in the weeds than I on that front within our organization. and are trying to be prepared on that front as well.
JP, Pritesh, what's your take on onboarding innovation?
Yeah, this is a forward-looking question. Like we design for today's requirement, but of course we build in flexibility for tomorrow's technology. So we take into consideration our future power, energy innovation, cooling strategies, and what the next generation infrastructure look like, and we account that in our today's budget and today's plan of construction. Because the worst thing you can do is lock yourself into a design that's obsolete before it's energized.
Yeah, so I think I might have a little more longer answer on this one. Yeah, so I led data hall design for all of Oracle before coming to this current role, right? So the Stargate in Abilene, I'm very familiar with that design, deployed in multiple different countries. 24 months ago, I realized the technology didn't exist to do the next cluster. So I came to Eaton to influence what I needed to build my next cluster. Typically, everything that's currently designed in the market is at a single order of magnitude design principle. Right now, we're struggling in a second order of magnitude design principle with these GB200s or the AMD's chipsets. We're not yet designing for a third order of magnitude. So you have to back that to a first order principle approach, reorient the problem, and design for third order of magnitude designs, but also the fungibility to do that. I'm at Eaton to drive fault ride through AI waveform mitigation and the shift to direct current because that's what's needed in 2030. Those solutions work. You just have to be willing to put the investment at the time, right? So the Open Compute project, power distribution, for the last 6 months, much of my life has been devoted to that with the power distribution flow. This Friday is the target for when the direct current version 1.0 white paper for that shift will be there. Also, what will be released is the first time a consolidated standards list globally for IAC and also NAM markets. So when you approach it in summary, you have to think about the first principle of the approach, like Eric just mentioned, right? Thermodynamics hasn't changed. Your method of approach to that thermodynamics and how you're doing congestion management does change. And it can be planned through from that approach, in my opinion, if you map the congestion management and allow you to have enough space to grow in the portion. The rack densities will increase for AI clusters, like Pritesh talked about, because eyeballs, data gravity, latency no longer is sensitive for training clusters in that use case, because then it becomes the electron and the molecule. So wherever that power island is for this current space, that's what we're solving. Once you flip to the inference, that'll be a different conversation. But the first principles of congestion management and how you're going to transport that data for a human experience improvement, that's what will always dictate how a data center is designed. The network has and shall ever dictate data hall designs and construction. I would look to a couple of the most recent announcements from NVIDIA and Oracle on how those networks are evolving, and that will help inform how to design the data center.
Is there is there a way that, and JP, you're talking about the 2030 horizon, and in my mind, it was far away. It's only 4 years away. So it's just like hard to keep track of years at the moment at the pace of change. But are we just trying to play catch up? Are we ahead of the curve? What's going on with everything we're building? Because I keep hearing more supply hitting the market in 27, 28, 29. Are we building the right things for the right future? Is there any sense of that currently on the market?
Is that to me or to Eric or
to anybody?
The need for AI, we are in the beginning of a new leverage revolution for the human race, right? So if you think about steam power, I'm a student of history. So look at the patterns that applied in steam power. Look at the patterns that applied in the electrification. If you mapped an 1890 to 2020 electric generation build out and compare that from 1990 to 2020 of the United States, and you map over those graphs, they're almost identical in how they came on for data centers and for power generation plants. After 2020, there was a very sharp uptick after that piece. So we're still in the phase where AI is a backup leverage mechanism for us. OpenClaw and Claude really have, among others, but those are my two favorite personally, but OpenClaw and Claude have created a very key revolution. OpenClaw in particular surpassed Claude within a month. And like that leverage effect will drive more demand, but then it changes from that training cluster versus the inference to the conversation that people are concerned that you're going to overbuild training. As you have more leverage, we keep making bigger and bigger universities, right? Universities is a knowledge generation center, similar to what, Eric and Pritesh or Crusoe and Stream are working on, in the fact that we're building knowledge centers and then utilization. Universities have gotten more complex and bigger as we produce that more knowledge. The amount of people using that knowledge hasn't changed because you have to use universities for two things: teach the worker how to do it and then advance more knowledge. But the university continues to grow as long as it's built effectively, in my opinion. I don't know if that was a wordy answer, Roman.
No. This is it's something that's very interesting, and you're bringing a couple more concepts. I think maybe for another discussion another day on how knowledge continually being generated in the world of AI. But Eric, Pritesh, do you wanna add anything else?
Yeah, a couple additional comments, and then how it relates to what we're building today. So, I mean, I had the same concern when I first came into the data center industry a little over a decade ago. Came in as an architect, didn't even know what a data center was. Went to the principal's office the very first week and was like, okay, can I really plan on doing this the rest of my career? Like, how long are we going to need to continue to build data centers? And the response I got stuck with me and has been useful ever since. Every time we develop a new technology as a species, whether it's a new chip, better cooling, better power efficiency, all we've done is figured out more ways to leverage that and in turn driven additional demand. We're just scratching the tip of the iceberg on AI right now, and there is far more to come than I think most of us can even imagine. So what does that mean in terms of how we plan facilities and how we develop today? Well, number one, we can't build fast enough and get access to enough power to even meet today's demand. So how are we dealing with the 5-year, 10-year problem? We're looking for land that is suitable for data center development. For us, that still, again, is tied to core markets because inference, I think, is going to become even more relevant in the future than it is today. And, for instance, take either autonomous vehicles or robots that might be performing surgery on you. These are things that are very capable for AI to take over at some point. Latency is going to be important for those types of inference protocols. So for us, core markets are still kind of our bread and butter. Power is going to continue to be a topic until small modular reactors or some other technology is easily deployable. We're going to continue to talk about where we have access to power in the interim. So those are the things that we are doing while continuing to maintain flexibility in the design of our individual facilities. Land and power in the right places is still going to be the answer.
Yeah, and then you hit the nail on the head, Eric and JP. Just wanted to add to that, Romain, that innovation isn't really a risk. It's a planning variable for the data center build-outs. And we build up like optionality into our sites so that we can adapt to the new technology even quicker without starting over. Because the goal of today's infrastructure ad is that it should be durable enough for today's demand and flexible enough for what's coming next. So it'll continue to be innovative, and every year there will be new addition, new changes to the data center design. And as we go on year over year, we'll keep adapting to the innovation and plan for the future accordingly.
And look, this is all great. I absolutely love what you guys are saying, right? And I keep reading the comments coming through. Michael, Sharmila, and Sasha. Thanks very much for putting your thoughts in there. I'm just gonna put one last question for the three of you. If I wasn't part and hadn't been part of the industry for the last 2 decades, it'd be really hard to understand the nuances, and maybe part of what we see in terms of the reactions to the implementation of those gigawatt factory AI factories that we see out there. Yet another term that's really hard to put your hands on, really, if you don't understand what's going on. It can be room for misinterpretation, misinformation, and so on in the general public. And I'm not saying that the general public is right or wrong. It depends on how they communicate and what they say. But what's going to make us actually change the perceptions? What's the levers? What have you seen actually out there as key levers for us communicating better, empowering the public to really understand what data centers of the future can be, and the current estate, actually, for that matter?
It's tricky. Number one, because a lot of the folks that show up to community meetings and design review boards and zoning discussions are usually the folks who come in knowing they're going to be against that development no matter what you say. So not engaging in negative debate, or to use online terminology, rage baiting, but to be thoughtful in how we answer questions, to truly show how we are partners and we care about community development and community improvement along with the development of our facilities. Some folks are just scared and uncertain. Other folks are going to be NIMBYs no matter what you say. And finding the people who are truly curious and interested in answering their questions in a thoughtful manner and sharing real data. When people come and say, well, how much water is your facility going to use? And my response is, well, actually, the most significant water usage we have on our Phoenix campus is irrigation, because we have to keep alive the plants that the city requires we put around our facility. And then describing how our closed loop chilled water system functions, engaging thoughtfully and proactively, and not trying to come across as a combatant, but to come across as a partner is key.
Cool, thank you, Eric. JP, Pritesh, what's your take on what it's going to take to change minds about data centers?
Yeah,
for me, it's go ahead, Pritesh. Go ahead.
Sorry, don't mean to interrupt, but yeah, today's data centers, like most people still don't know data centers exist. So we need to kill the stereotype first. A lot of people still believe that when they imagine data center, it's a cold room with blinking lights. That's 2010. But today's AI data centers are like closer to industrial power plants, and they are ranging from 50 to 500 megawatts, thousands of GPUs running at extreme density, liquid cooling infrastructure. And some data center projects have construction budget that can rival to the entire hospital or public infrastructure such as airports. So we need to make it relatable, let them educate and tell about like what data centers are actually being utilized every time there is a someone sends a text, someone do the Google search, it's running somewhere in the data center. And for tomorrow, what data centers are actually building, we need to educate them that we are building an ecosystem. We're not just building a data center or a building. We are building an ecosystem that integrates power generation, waste heat recovery, water recycling, and potentially like on-site renewable power plants. And the entire facility is becoming a node in the broader energy and compute network, which is going to be used for next generation and future of infrastructure. So it not just the AI factory, not just the storage room, but the language and the education is already shifting from. It's a part of living, and like food, clothes, shelters, and data centers gonna be added to that as a basic human need for future.
Thank you, Pritesh. JP, for the closing comment for today.
Yeah, so I think it comes down to what was said before, the empathy, and then tying it to the human experience, right? So my most personal one I like to share is, over a year ago, my mom got a firmware upgrade on her hearing aids. That firmware upgrade was trained in a data center to be able to use AI to sort out language from background noise. And what that enabled her was to hear her grandchildren again. Right? So it enhances the connection amongst generations and families so that you can interact with your grandchildren. Additionally, my wife also has hearing problems. So she has similar upgrades so she can hear her children. And those are things that didn't exist 10, 15 years ago. Right? But with the technologies that we're developing, we're able to improve the human experience and allow us to connect with our loved ones, interact with the world, and have a much more value-centered life and have a retirement with dignity, which is what I really care about for my mother. And that's what I feel data centers do.
That's an amazing closing comment, and couldn't wish for a better one. Thank you very much, JP, for sharing that experience. As we're coming to a close, I just wanted to bring to all of the people here on the call today, but also watching this later on, we're bringing on the page how you can engage. If you like the call that we've had today and the content, we've got another 5 like this coming up later in the year. Again, we're going to have thematics and people coming to speak. And a Q&A. We've got the same thing coming up with some of the startups that we've got in our incubator. So if you want to get involved, please scan the QR code. I'm going to leave that another couple of minutes. If you want to learn more about the upcoming events, at the same time, just go to imasons.org/events. Every single one of those are going to be on there. And then finally, if you want to reach out to the groups that actually managing innovation, in particular, I'm really thinking about the people behind everything that's going on. Elena, Asa, Stoll, Caesar, Gina, and the rest of the team. Please email us innovations. We can actually just help you figure out what we're going on, how you can get involved, but also connect you to other parts of the association if you want to. So by all means, feel free to go ahead. The only thing that's left for me is to thank all of our panelists today for all of their brilliant insights. Really appreciate the thoughts and efforts that's come into their presentations, but also the openness in the Q&A on the second part. So on that note, thank you very much, everybody, and we look forward to seeing you again very soon. All right. Take care, everybody.